I'm starting with a new project I've called Streams. I'm going to set up a collections example and then show you how to do the same thing using streams. Inside the main method, I'll be creating a list of strings to represent the ball labels in a bingo game. If you haven't ever played bingo, or if you've never played in person, there's usually a container of labelled balls. Each ball is identified with either a B, I, N, G or O and followed by a number. A B ball will have a number from 1 to 15, an I ball will get a number between 16 through 30, and so on. Someone will draw a ball out of the container, if you're playing in a physical setting, and announce it. Every player will have a 5x5 card with some randomly generated set of these numbers on it. The first column has the B numbers, the second column has the I numbers, and so on. You win by being the first person to match 5 called numbers in a row, either horizontally, vertically, or diagonally. I'll be using this bingo example for the next few videos. The first thing I want to do is create a collection of all possible 75 bingo balls, or labels. I'll set up my array list of string, calling it bingo pool. It's a new array list and I've set the initial capacity of the array list to 75 elements. The first number on a ball starts at 1, so I want a local variable start, and that gets set to 1. I'll set up an enhanced for loop to iterate over the characters. I'll use the literal string bingo with the tochar array to get a character array. This means I'll be looping through the characters in the bingo word. I want a nested loop with 15 iterations. Each letter will get 15 different numbers, but for each letter, these numbers will increase by 15. If I just passed C plus I to this method, I'd get an integer back as a result, not the character letter concatenated to the integer value. If I start with an empty string, the values are concatenated. Next, I'll print out each generated ball label. After each letter is processed, I need to increase the starting number by 15. If I run this code, I'll get 75 labels printed out from B1 to O75. Next, I want to comment out that println statement in the for loop, since I've confirmed this is working. I'll shuffle these using collections.shuffle, passing it my bingo pool. After they're shuffled, I'll print the first 15. I'll use a traditional for loop to do this, stopping after 15 iterations. I'll include a separation line here. Running this now. I'll see the first 15 shuffled labels. I'll assign those first 15 to another list variable called first ones by using sublist with the arguments 0 and 15. I'll now sort these first 15 in natural order, meaning the string order. I'll use the replace all method to do some kind of transformation on each one. Actually, I'll only do this for the G&O labels. Let's just say I want to add a dash between the character and the number so that the G&O are more easily visible to the reader. I'll print the updated label for this selected group. I'll return the new label, which will replace the old label in the list. If it's not an O or a G label, I will just keep the old value, so I'll return that. I'll print a new line and a separator line. Running this code now. The result will be different each time, but you should see a sorted list of the G&O labels with dashes included. Okay, so nothing particularly interesting here yet. I'm creating a collection, shuffling it, getting a sublist, and filtering part of it to do some kind of transformation on that set of elements. I'm going to next print the first 15 labels again from my bingo pool list. I'll copy lines 24 through 27 and paste those statements at the end of my main method, starting on line 41. I'll run this. What I want you to see is that everything I did to my first ones list was done to the bingo pool list. This is just a reminder that the sublist method returns a view, and to use sublist only when you really do want to alter the original list. If I didn't want these changes to affect my original shuffled bingo pool, and I don't here, then I should make a modifiable copy of the sublist. I can do this by creating a new array list and passing that sublist to it. I'll copy line 29 and paste it on line 30. I'll comment out that first assignment on line 29. On line 30, I'll wrap a new array list instance around that call to sublist. I will run this code again. And now you can see I haven't changed anything on the original bingo pool list. It's the same as it was previously. Next, I want to do the same kind of thing on the first 15 labels using a stream. You may have noticed in your own research of the collection interface and its methods that it declares both a stream and parallel stream method. That means we can create a stream from any collection type, and I'll do that here with the bingo pool. That returns an implementation of the stream interface, and in this case, the type of implementation isn't important. Having a stream, I now have access to all of the stream methods, so I can chain them to this stream. It's common practice to start each new chained operation on its own line, starting with the dot in the chain. I'll start with a function called limit, which limits the number of elements I get from the stream. Like before, I just want the first 15, and I can do this by passing that value to the limit operation as the first operation. I'll next call filter and pass this operation the same condition I had before to get the G and O labels. I'll follow this with dot map, which you can think of as similar to the replace all method on collections. I'll add that dash between the character and number. I'll sort the stream at this point. Finally, I'll print each label followed by a space on one line, running this code. I get the same set of labels in the same format as the code above. For good measure, I'll copy lines 40 through 44, pasting those statements at the end of the method to see if this code had any effect on the original bingo pool collection, running that. You can see that my first 15 elements on the bingo pool are unchanged. This stream code didn't have any effect on it. Take a minute to compare the code on lines 30 to 39 with that on lines 47 to 52. The stream code is a little more concise, meaning one or two statements less, but it's a lot more readable and ordered. Also, the code above was left to the programmer to decide and implement both what to do and how to get the job done. With streams, there's a pattern of operations to choose from, which means the developer just describes what needs to be done and doesn't have to code the how to do it part. The results are also different from these two segments of code. In the first, I have an array list of 15 labels, and I've changed a few of those labels in that list. In the second segment of code, I'm simply printing information out about a subset of the data after I've filtered and transformed it. Right now, it's not collecting results into a variable, though I could have done that as well. Each executable step in this second segment of code is called an operation when using streams. I'll be covering each of these operations and quite a few more over the course of the next couple of videos, but this chain, this listing of these 5 operations in this particular order, is called a stream pipeline. This is what I want to examine next, because not all operations in the pipeline are equal. I'll end this video here, and in the next video I'll be talking about the structure of this stream pipeline.